In 1.4, we're going to continue our discussion of lines and our slope and some applications of lines and slope. So just a refresher about the slope formula. Our slope m is subtract the y's over subtract the x's, or in other words, the change in y over the change in x. In the next block, we're going to look at some equations of lines. We already talked about the slope-intercept form in the last section. We also have a point slope form, which is y minus y sub 1 equal to mx minus x sub 1. I know you guys are all familiar with this form. And where that comes from is actually from the slope equation. Imagine in the slope equation that you multiply both sides by x sub 2 minus x sub 1, and then you get that equation for the point slope form. We also have a standard or general form. Notice that it's an uppercase A and an uppercase B and an uppercase C. And the only reason why the general form is written with those uppercase letters is so that you don't confuse those values, the ones that are in y is equal to mx plus b. So those b values are not the same. It's not the same as the a value that's in a vertical line. So a vertical line is just x equal to a, where a is just some number. Remember, the slope of a vertical line is undefined. And finally, the last line is our horizontal line, which is y equal to b. And in this case, m is equal to 0. So something we haven't really talked about yet are the ideas of parallel lines and perpendicular lines. If lines are parallel, they will have the same slope because they're going in the same direction. If lines are perpendicular, then they're going to intersect and form right angles. In that case, perpendicular lines will have opposite reciprocal slopes. So all that means that if you do have perpendicular lines, let's say they have a slope m sub 1 and m sub 2, that one slope, say m sub 1, is going to be the opposite or negative reciprocal of the other slope. Another way to look at the properties of slopes that go with perpendicular lines is that when you multiply the two, you're going to get -1. So the exception to this would be vertical and horizontal lines. Notice that when you multiply the slopes of vertical and horizontal lines, you don't get -1 because the slope of a horizontal line is 0. The slope of a vertical line is undefined. So in fact, all vertical lines are perpendicular to all horizontal lines, but they don't follow that property of negative reciprocal, or the product is equal to -1. Now we're not going to really graph using those different forms of an equation, because basically when you graph a linear function or a linear equation, all you're doing is just plotting points. It doesn't matter the form that the equation's in, be it point slope or slope intercept, or the general form, you just plot points. So we're just going to do a few examples in this section. In example 1, we're going to explore this idea of parallel perpendicular lines. Let's say we want to find the equation of a line, and we want to write that equation in slope-intercept form. Our line is going to pass through the point -4, 1. So part A tells us that our line is going to be parallel to a line passing through the point 1, -3 and 4, 5. When I write the equation of a line, and here they want us to write in the form y equal to mx plus b, the slope-intercept form, I need a slope, m, but I also need b. B is a y-intercept. The point I have, -4, 1, is not a y-intercept. And the reason why I know that, because in order for it to be a y-intercept, the x value has to be 0. That x value is -4. So I don't get b, I don't have the slope. But I do know that my line is parallel to the line passing through those two given points. So if I can find the slope of that line, then I have the slope of my line. That would be the first step. Find the slope. And I'll just call the first point x sub 1, y sub 1. Second point x sub 2, y sub 2. So that when we do the y sub 2 minus y sub 1, it's going to be 5 minus a negative 3 over x's would be 4 minus 1. So we have a 5 plus 3. That's going to be 8 over 3. So 8/3 is our slope. So I have my slope. I just need that value b. And there's two ways that I can find that value b. The first way would be to look at that y is equal to mx plus d. Put in our slope, 8/3. Again, I know the slope is 8/3 because my line is parallel to the line passing through those given points, and that line has a slope of 8/3. And we know that our line is going to pass through the point negative 4, 1. So we can look at that as our x and our y value. And just plug in negative 4 for x and positive 1 for y. And solve for b. So 8/3 times negative 4 is going to be negative 32 over 3. And then I would simply add the negative 32 over 3 to both sides. Now I know that 1 is going to end up being 3 over 3, so I'm just going to write it right now. That would be my b value. It's 35 over 3. I have my b value, I have my m. I can now write the equation of the line, which would be y equal to 8/3 x plus 35 over 3. We didn't have to use the y equal to mx plus b in the start. Once we find the slope, what we could have done is used a point slope form because we do have a point. We could call the negative 4 the x sub 1, and we could call the 1 y sub 1. And we could have used y minus y sub 1 equal to m, and we already knew that m was 8/3. We found that already. X minus x sub 1. So y sub 1 would be 1. We'd have y minus 1 equal to 8/3. X minus a negative 4 would be x plus 4. And then simply distribute the 8/3 to get 8/3 x plus 32 over 3, and add the 1 to both sides. When I add the 1, I'm just going to write it as 3 over 3 because I know I have to combine those two fractions to get y equal to 8/3 x plus 35 over 3, which is exactly what we had when we started out with the slope-intercept form and then found the b value. So either one of those methods will work. Let's look at part B. Part B, we're supposed to find the equation of the line passing through that point, negative 4, 1, but this time it's perpendicular to the line passing through 1, comma, negative 3, 4, comma, 5. So we already figured out the slope for that line. Remember, it was 8/3, but this time our line is going to be perpendicular to that one. So the slope that I want to use is the negative reciprocal, or negative 3 over 8. And then all I have to do is plug that in for the slope using either the slope intercept or the point slope form. I'm going to use the point slope form. I'm going to use y minus, now remember y sub 1 was 1, is equal to negative 3 over 8 x minus a negative 4, so plus 4. And then I need to write my final answer in slope intercept form, so I will do the math. Y minus 1 equal to negative 3 over 8x minus 12 over 8 will turn into 3 over 2. So we have y equal to negative 3/8 x minus 3 over 2. The plus 1 would be a plus 2 over 2, which gives me y equal to negative 3/8 x minus 1/2. Okay, so we just have two examples that we want to go over. Again, the important part is to be able to apply these linear equations. In example 2, we have a computer that we purchased for $1,000 in 2018. In 2021, the value of the computer has depreciated, so it's lost some value. So now the value of the computer is $550, and we're going to assume the rate of depreciation is linear, meaning that the graph of the value of this computer would be the graph of a line. In part A, it says find an equation in point slope form that models the value of the computer. So we have to be careful about what we're being asked to do. We're trying to find an equation in point slope form. So let's look at part A. Well, I need points and I need a slope, and we have to choose those. Well, the equation is supposed to model the value of the computer. The value of the computer is going to be our y value. So in the first dollar amount, that $1,000 in 2018, the $1,000 would be our first y value, which is our y sub 1. And the 2018, the time is going to be our year. So this would be our x sub 1. And then we're going on to the year 2021. So that would be our x sub 2. The value of the computer now is $550. That would be our y sub 2, which means we have these 2 points. Remember, it's x sub 1, which would be 2018. Y sub 1 is 1,000. The next x value would be 2021 with a y value of 550. I need to find my slope, and I do have 2 points. My slope is going to be my y sub 2, which was 550, minus y sub 1, which is 1,000, over my x value 2021 minus 2018. So that would give me a negative 450 over 3, which would be a negative 150. Now remember, that's our slope. And what we're comparing is our top value would be the value of the computer in dollars, right? Over the time in years. In part B, forgot to find the equation of the line. So I have 2 points that I could use. Since I call 2018 my x sub 1 and 1,000 my y sub 1, I'll use that in the point slope form, which would be y minus y sub 1 is 1,000 equal to m, which is a negative 150 times x minus 2018. You're going to need a calculator for this one. So that is the equation in point slope form. In part B, we're just discussing what that slope means. Well, it's a negative slope, so that means we're losing value. So we're losing $150 in value on the computer per year. So maybe we'll write the computer depreciates at a rate of $150 per year. In part C, we're supposed to figure out when the value of the computer will be 0. Okay, and there's a variety of ways you can do that. We do have an equation. Remember, the value of the computer is the y value. So if I just substitute 0 in for y in my equation from part A to get 0 minus 1,000 equal to negative 150 x minus 2018, and then just solve for x. Remember, x is the year, so that would be the when in the question. So in other words, what year will the value of the computer be 0? If I were to solve this equation, I would distribute the negative 150, or you can multiply both sides by a negative to get positive values, but I'll just go ahead and distribute the negative 150. And now in your calculator, if you put that in, let's see, I get 302,700. You guys check me on that. And if I minus that from both sides, it looks like I would have a negative 303700 equal to negative 150, x. So dividing both sides by 150, again, I'm going to do this in my calculator. 2024.7 is equal to x. Remember, x is the year. So what that says is that in 2024, there's still a little value left because of this 0.7. We're going beyond the year 2024 and into the year 2025. So it's, the when would actually be in the year 2025. That's when the computer will lose all of its value. So this is not the only way we could have figured out part C. What you could do is just note that in 2022, we would have the ending value of 550 because that was the value of the computer in 2021. And since the computer depreciates or loses $150 per year, in the year 2022, the value of the computer would simply be 550 minus 150. So that would be $400. So in the year 2022, the computer is still worth $400. So what about 2023, a year later? Well, we ended off with 400. If we subtract 150 again, we have 250. So computer still has values. Let's look at 2024. Start off at 250, we minus 150, we end up with $100. So again, in the year 2024, the computer still has value. So in 2025, we're at 100 minus 150, we get a negative 50, which tells us that the value of the computer has gone beyond 0. So sometime in the year 2025, the computer will be worth nothing. And there are other ways to do this. Going back to this idea of subtracting 150 every year, what we could have done is simply taken the ending value in 2021 of 550 minus 150, and I'll use a different variable. I'll do t. So this represents the value of the computer. We want that to be equal to 0. So you could have done that. And here t is going to be, it's not the year, it's the number of years. Okay, so t is going to be the number of years, not the actual year. So just another way that we could solve. I'm going to go ahead and just add the 150t to both sides so everything's positive. And then you would simply divide by 150 in my calculator. I get 3.66666, so about 3.7. So that means 2021, I'm going to add 3.7 years to 2021 to get the year 2024.7 because it's 3.7 years after 2021. So that would be past the year 2024, and we're already, because of this 0.7, we're already in the year 2025. All right, so that's one application. That took a little bit of thought. Let's look at another application. And these are real figures. You could actually go into the Windward Community College website under institutional research way at the bottom, and you could find the figures in this following table. In example 3, you have this table, and what the table does is it gives us the number of Native Hawaiian students that were enrolled in Windward from 2018 to 2021. In part A, we want to find the equation of the line y equal to mx plus b that passes through the point 2018, 1007, and 2021, 1976. So we have these 2 points. I'm automatically going to label the first one x sub 1, y sub 1, and the second one x sub 2, y sub 2, because I know I have to find the equation of a line. And I have 2 points. First thing I want to do, find the slope. In part A, when I find the slope, it's going to be my y's, so 1976 minus 1007 over the year 2021 minus 2018. So this is 969 over 3, and I end up with a positive 323. So positive slope. And remember that line represents the number of Native Hawaiians enrolled at WCC. So a positive slope means that number is increasing as the years go on. Okay, so remember what that slope means. This is students, the number of students, Hawaiian students, per year. We have our slope. Now we need the equation of the line. I have 2 points, so I'm just going to start out with the point slope form and then get rid of parentheses and all that stuff to get down to the slope intercept form. That's usually my method of choice. So we have y minus, our y sub 1 is 1007, is equal to m, which we found to be 323x, and then our x value is going to be 2018, so x minus 2018. And I'm pretty sure I'm going to need to use a calculator for this. So I have 323x minus, in a calculator, I have 651,814. Again, double check me on that. Or maybe I'll do the other method where I start out with the slope-intercept form and see if these two equations that I get will be the same. Maybe I'll check that way. The last thing I want to do is add 1007 to both sides. And when I do that, again, I'm just using a calculator. I have a minus 650,807. This would be the equation in slope-intercept form. But let's go back and try this starting out with the slope-intercept. So remember, we found the slope. The slope was 323. So y is equal to 323x plus b. So I'm going to use that first point, the 2018, 1007. So I'll put in 1007 for y, 323 times 2018 for x, and then I will solve this for b. Again, in my calculator, I get 650. Okay. Oops. Let's see. No, I got 651,814. And then if I subtract that from both sides, I get the 650, but it's negative. 650,807, which was my b value. And we get y equal to 323x minus 650,807. Is that what I got before? Yeah, that's what I got before, which tells me that that's probably the correct equation. Part A, we just had to find the equation. In B, we want to use this equation that we found to estimate the number of Native Hawaiian students enrolled at Windward in the year 2020. Now, if I look at the table that was given, the year 2020 already gives me the number of students. The point of this is to compare our estimation using the slope. Remember, the slope would be the average rate of change. So the average increase in the students would be 323 students per year. So if this is a linear model, then when I use the equation and I put in my x value, which would be 2020, I should get the y value of 1018 because that corresponds to the year 2020 in the table. I don't think I will. So again, we're trying to solve for y. The year we're looking at is the year 2020. So I'm going to put that in for my x value. Maybe I should have left a little bit more space. 650,807. And I will just put that whole thing in a calculator. 1653. So in the year 2020, if this were a linear function, then in the year 2020, there should be 1,653 Native Hawaiian students enrolled at Windward. Again, looking up at that table, there's only 1,018. So that tells me that this table, if I were to plot all those points in a graph, would not be linear. I could not draw a line through all of those points. So this is not a linear model. In part C, it says compare the estimate from part B, which we did, and that's a lot higher than the actual value, because our estimate was 1,653 students. The actual value is only 1,018. So let's discuss the results. So what could have happened in 2020 that would drop the population of our students, especially the Native Hawaiian students? Well, COVID. Probably the hugest thing would be COVID. A couple things happened when COVID entered our lives. One was everything went online pretty quickly. So a lot of students were not comfortable with that format. Not only that, a lot of instructors were not comfortable teaching in that format. So the classes were maybe not so great for the students, and a lot of students ended up withdrawing. So we lost them, and they decided not to come back because we remained online for the following semester in the fall of 2020. Another thing is that people lost jobs. Tourism was a huge income for Hawaii, and everything was shut down. We were isolated. We didn't have that money coming in. A lot of people lost their jobs. So many of our students actually had to go out and find jobs to support their families. And think about it, on the windward side, we tend to have students living with extended families. So there's a lot of responsibility there. COVID really impacted our lives, and we can see it by the huge drop in enrollment that we had. And look at the following year in 2021, it jumped back up again. So COVID is not the only reason why the enrollment went down, but it's a big part of the reason why the enrollment went down. And that's a really nice application of our linear equations and our slopes. So that is it for this section.